HG5.1. It's on mid-segments. So they're telling you that segment MP is a mid-segment of the triangle LNO. Find the value of x. So if this is a mid-segment, here's what that means. That means that point M is a midpoint. So if they weren't going to tell you that it was a mid-segment, they would probably have these marks here to show you that that is a midpoint. Likewise, point P needs to be a midpoint as well. Again, look at the different marks here. These are the same, and these are the same, but these don't have to be. That's what a midsegment is, by definition. Now, there's a theorem that tells you two things about midsegments. It tells you that this segment is parallel to this segment, so you know this. Also, you know that this midsegment is half the length of that side. So this x needs to be half the length of that side, so it's going to be 8. And that's how we're going to do all of these. This is a midsegment, so this guy is twice as big. Be careful here. This is a midsegment, so that means that these lengths are equal. So that value of x is 4. This value of x is 9. This is twice as big as that. In triangle DEF, they're telling you that segment EJ, I'm going to mark it, is congruent to segment JF. Also, segment FK is congruent to segment KD. Segment DG is congruent to segment GE. They didn't tell you that these were midsegments, but if you look at the diagram, they are midsegments. Also, here's a good time to go over this as well. If we're looking at this side length, let's pretend this side length is 10. Wouldn't that make this 5? Now, if I go back to here and say that this is 10, wouldn't this be 5? Wouldn't this be 5? This is 5 as well. So if you wanted to, you could put the same matching marks there. This is definitely the same length as those. Likewise, you can make those marks as well. Now, inside this one triangle, this is kind of neat. You actually have 4 triangles, and they're all congruent by side, side, side. So if you know one piece of information about any one of these triangles, you know that same corresponding part in all the rest of the triangles. Okay? So, what is segment GJ parallel to? Well, it's parallel to this segment down here. That's what the mid-segment theorem tells you. It's parallel to segment DF. Segment EJ, that's this one. What's it congruent to? It's congruent to segment JF, and it's congruent to segment GK. Number 7, segment DE. What's it parallel to? Segment JK. Number 8, segment GJ is congruent to segment DK and is congruent to segment KF. Use the diagram of triangle XYZ where points U, V, and W are midpoints. So it's kind of neat how they set up this worksheet. They're telling you these are midsegments. That's one way to do it. Down here, they're telling you where segments are congruent. That's another way to say that these are midsegments. And then down here, they're telling you that these points are midpoints. So if they do that, that's also another way to tell you that these are midsegments. Number 9, if distance from U to W is 4x minus 1, and the distance from Y to Z is 5x plus 4, how far is it from U to W? Okay, so we're using variables now. Is this the same length as this? They're definitely not. So I'm coming down here. This 4x minus 1, that's your midsegment. This 5x plus 4, that's your entire side length. They're not the same. But if you multiplied the midsegment by 2, then they would be the same. Subtract 5x from both sides. Divide by 3. You get x is 2. Now, that's not your answer. They're asking you how far it is from u to w. Well, if x is 2, then 4 times 2 is 8. 8 minus 1 is 7. That's your answer. Number 10, find the distance from y to v. Here's y, here's v. Well, I know it's the same as this guy, remember? So it's also 7.